Kia ora Year 12 and 13. This video has detailed answers to questions 4 and 5 from the revision sheet that I gave out in class. Concise answers are up on Moodle in PDF form. So we're looking at a general solution problem, and general solutions to sine equations come in this form. Theta equals n pi plus negative 1 to the power of n times alpha. In this case we are going to be working with the stuff in the brackets next to the sine function. So we start by doing a little bit of rearranging. We get sine of 4x minus pi on 6 equals negative 1/5. Right, okay, so I've subtracted 3 off both sides, then I've divided through by 5. So at this point I'm going to figure out alpha. So alpha is equal to the angle whose sine is negative 1/5. That works out to be negative 0.20136. Now if you're thinking about that, where that's coming from is here's your sine curve, basic sine curve with no transformations, and it's saying what is the value here that will give me the sine of an angle is negative 1/5. Right? And it turns out to be negative 0.20136. So that's our alpha, and we're going to use that in our general solutions formula. Okay, so we've got alpha equals negative 0.20136, and we have our general solution is the sine of 4x minus pi on 6 will equal n pi plus negative 1 to the n times negative 0.20136. All we need to do now is to clean this up and make x the subject. So I'll do that in several steps. First we're going to get 4x is equal to n pi plus pi on 6. I've got a negative number here, so I'm going to make that minus negative 1 to the n times 0.20136. It just looks much cleaner that way. Now I'm dividing through both sides by 4, and I get my final answer, which is x equals n pi on 4 plus pi divided by 24 minus negative 1 to the n times 0.0503. Okay, so that's all there is to it, and n in there is equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on forever and ever. In other words, any integer value of n can be substituted into that formula and will solve that equation. Okay, on to the two proof questions. Okay, next question is a proof question. We need to prove this identity. So having a look at what the options are here, we've got sine of 3x. Now, we don't know explicitly how to write that yet, but we do know how to write out sine of a plus b. Sine of a plus b is sine of a, cos of b, minus, cos of a, plus cos of a, sine of b. So we can break out 3x into 2x plus x and hope that some simplifying is going to be possible. So sine of 3x equals sine of 2x plus x, which is equal to sine of 2x cos of x plus cos of 2x sine of x. Now, two things to do next here. The first one is to remember that we can now expand out sine of 2x. That will get us down to building blocks of sine x and cos of x. For cos of 2x we've got three choices, and we always need to have a think about which one might be most useful for where we're heading. So take a look back up here at where we're trying to get to. We want to end up with something with just sines in it. So when we're thinking about what to do with cos of 2x, this middle one, which has got 1 minus 2 sine squared, looks like the most promising. Okay, so expanding this, we're going to get 2 sine of x cos of x times cos of x plus 1 minus 2 sine squared of x sine of x. So that equals 2 sine of x cos squared of x plus sine of x minus 2 sine cubed of x. Right, now we're not quite there yet, but we're starting to have some sine of x terms. We've got a sine cubed of x coming. We still have this messy thing here. But when we see a cos of x, we need to think about our most basic level 3 trig identity, which is this one here. Cos squared of x plus sine squared of x equals 1. So we can always rewrite a cos squared as a 1 minus sine squared and vice versa. So we're going to do that now on the next slide. Okay, so just rewriting where we were, we've got 2 sine of x cos squared of x plus sine of x minus 2 sine cubed of x. So we replace the cos squared of x with 1 minus sine squared of x. And I've stated why I'm doing that on the page before. Remember to try to show your reasoning. So if you're using a trig identity, you need to be pretty clear about that. So just writing out the rest of that. Okay, so that's 2 sine x minus 2 sine cubed x plus sine of x minus 2 sine cubed of x. So that equals 3 sine of x. And I'm just collecting up like terms. Minus 4 sine cubed of x as required. So we're done. Right, so it's just careful choice of different trig identities, substituting and collecting up like terms. Right, on to problem number 5b. Okay, so the next identity we're going to prove is this one. Oops. Sine of 2a minus sine of a over cos of 2a minus cos of a plus 1. Right, nicest to pop those brackets in there. We're going to start by doing this substitution on the left hand side. I'll just tidy up my working a bit. So we start by writing out what we've got on the left hand side. So sine of 2a minus sine of a over cos of 2a minus cos of a plus 1. So substituting 2 sine a cos a minus sine of a over the denominator. So this is 2 sine of a cos of a minus sine of a. Right, in the denominator I've got some choices about what I substitute for cos of 2a. But what I know is that I've got a plus 1 in that denominator here. It'd be quite nice to undo that plus 1 with a minus 1. So think about your 3 versions of cos of 2a. Which one has got a minus 1 in it? Well, it's 2 cos squared of a minus 1. So make that substitution here. So we'll do 2 cos squared of a minus 1 minus cos of a plus 1. So some good things start to happen here. I'm going to put a new slide in. Right, so this is where we were up to. 2 sine a cos a minus sine of a over 2 cos squared of a minus 1 minus cos of a plus 1. I can do 2 things here. I can factorise the numerator with sine of a times 2 cos of a minus 1, and in the denominator, minus 1 and the plus 1 have added to 0. I've got cos of a times 2 cos of a minus 1. Okay, so if I divide numerator and denominator by the common factor, whoosh, I'm left with sine of a over cos of a, which is tan of a, as required. So we're done. Okay, hope that helped. I will try and do a couple of the other identity ones later on today. Thanks for watching.